Okay, hey everyone, it's me, your instructor, Mr. Von Tagen. I have a question here from Angela in regards to section 1.4 and 1.5 homeworks on the MyMathLab. So this may not be the same question on your MyMathLab, but it'll be fairly similar. It's question number 32. And essentially the question says this, that men at the age of 90 have a 15.125% chance of dying during that year. Then suppose we have three men gathered together. What's the probability of all three men dying during that year? What we need to recognize in this case is that we're dealing with three independent events. Okay, that is, we've got the event of the first man dying, and the second, and the third. Okay, each one of these events is independent from the other. Okay, so remember that for just two independent events, we say that the probability of A and B occurring, okay, we could write A and B occurring, that's equal to the probability of A times the probability of B. This is provided they are independent. So in this case, we've got three events, and the three events, the probability of the first man dying, the second man dying, and the third man dying, we need to recognize that these are independent. That is, if the first man dies or doesn't die, that has no bearing on the probability of whether or not the second man dies. Okay, that the occurrence of the first event does not affect the probability of the occurrence of the second. Okay, so in this case, the probability of all three men dying that's just equal to the probability of the first dying times the probability of the second dying times the probability, excuse me, let's see here, there we go, switch that over, times the probability of the third dying. Okay. Well, what is the probability of the first man dying that year? Well, he's got a 15.125% chance of dying, so the probability of him dying is 0.15125. Okay. Well, what's the probability of the second man dying? And here's the key. Because these events are independent events, okay, then the occurrence of the first event does not affect the probability of the second man dying. Okay, so we're assuming, I guess, that this isn't some sort of contagious disease or anything. And thank you. So the probability of the second man dying is again 0.15125. Okay, and the same is true for the same reasons for the third man. So 0.15125. So if you wanted to calculate it like that, that's fine, or you could recognize that that's 0.15125 cubed, and then I'll just crunch that on my calculator. Okay. When I crunch this on my calculator, I'm going to go ahead and round it, but I get approximately 0.00346 and there's some additional decimal points, but the instructions in the MyMathLab will ask you to simply round this to 4 decimal places, so that is approximately then, and this is what you would enter, 0.0035 in this case. That's the probability. The 0.0035 is the probability of all three men dying.